Welcome back, my students. We're in lesson 19 today. We're going to talk about exponents first. An exponent is just a little number that we write at the top of another number to tell us how many times to use the big number as a factor. So for instance, if we have 3 to the second power, that's how we say that, that's going to be the same as saying 3 times 3. We use that 2 times. And then that our answer would be 9. So we could actually say 3 squared equals 9. We can skip this entirely. If we were to write 3 to the 5th power, we would say 3 times 3 times 3 times 3 times 3, which is 243. Okay. We could even do a negative number. Let's say we do negative 3 to the 4th power. However, there's something we have to remember when we move on to negatives, and that is that the exponent only applies to the number that it touches. So that means that this negative is not a part of the exponent. So this actually would look like the negative, or the opposite of 3 times 3 times 3 times 3. That is what that would translate into, which would give us a negative 81. However, if we write it like this, where the negative is included with the 3, then we have negative 3 times negative 3 times negative 3 times negative 3, and because we have pair here and a pair here, we have even amount of negative signs, it is a positive 81. So how this is written matters. The value of the constant will be the same, but whether or not it's positive or negative will be determined by whether or not it is included with parentheses or it's left to its own devices. And if the negative is not included here with parentheses, then it's the opposite of 3 to the 4th, which is what this says right here. The opposite of 3 to the 4th. Okay. So make that distinction whenever you look at exponents. So let's try some practice problems. I'm going to clear this page. Take these notes down if you need to. These are good examples for you to follow. All right, so let's do 19.1. These are pretty quick. 19.1 just says to, we just did all of these. So let's do 19.2. And this says to do negative 3 squared, negative 3 cubed, and negative 3 to the 4th, which we've already done, and the negative of negative 3 to the 4th. It's supposed to be parentheses. My pen is not doing right. So we know that this is negative 3 times negative 3, which is going to be positive 9. This is negative 3 times negative 3 times negative 3, which is going to be a negative 27 because there's an odd number of negative symbols. This is going to have an even number of negative symbols because we're using negative 3 4 times. So it's going to be a positive 81. However, when we get down here to negative 3 4 times, which is the same thing up here, is asking us to make it a negative. So that'd be a negative 81. Okay, 19.3. Let's look at that. We have an actual problem to solve. So we have negative 3 cubed minus negative 3 squared plus negative 2 squared. And all that. This is in parentheses. There we go. All right, so let's look. PEMDAS tells us to look for parentheses first. Okay, but there's no operations within the parentheses, so we can move on to exponents. So let's look at this exponent. We have 3 times, and then we want the opposite of that. So that's going to be 27, and the opposite of 27 is negative 27. All right, we have negative 3 2 times. That's going to be 9. We want the opposite of that, so it's negative 9. And we have negative 2 2 times. So that's going to be 4, and it stays positive. And when we add all of these up, our answer is negative 32. Okay. Negative 27 and a negative 9 combined is going to give us a negative 36. Combined with the positive 4 is going to be a negative 32. That's how we got there. Let's do 19.4. We have negative 2 squared minus 4. Oops, sorry. Not a parenthesis there. That's a 4. But now that's a parenthesis, and that's negative 3 to the third. And then we have minus 2 squared minus 2. All right, so let's see what we do. Let me let you solve this one. Pause the video and solve this problem and see what you get. And if you get the same answer that I do, that's awesome. If you don't, then you can message me and we'll go through it. All right, if you got positive 94 as your answer, then you are correct. So we had a negative 2 squared. So that should be, the 2 is attached, the exponent's attached to the 2. So it's 2 times 2 is 4, and then you bring down the negative and get the opposite. All right, in our next term, we have negative 3 cubed. So that's negative 3 times negative 3 times negative 3. That's going to be a negative 27, right? And that's times a negative 4. So it's a positive. And you have a negative 4 times negative 27. That's a positive 108. Now we have negative 2 squared. That's going to be positive 4 times negative 2. That's negative 8. And then we bring down the negative 2. So I combined the first two terms and got 104. Combine the second two terms and got a negative 10. 104 minus 10 is 94. And that is our answer. So I hope you see and are getting the hang of how to use these negatives with the exponents. That's probably the trickiest part, is understanding when they're applied and when they're not applied. So let's move on and talk about roots. So roots are like the opposite of exponents. So if we had 3 squared, that would be 9, right? Well, if you wanted to undo 9 and find the square root of that, you would do it like this. You would say 9. This is a radical sign. That's what it's called. And the whole thing together is a radical as well. But what this does is this asks you what times what gives me 9. And it's asking for that answer. And the answer is, of course, 3. When you see this sign, it is a square root, meaning that the exponent it's looking for is 2. It means something times itself. Now, the easiest way to solve these is just to create a factor tree, just to find the factors of this product underneath the radical sign. There are other options. It's not always looking for a pair. Sometimes it's looking for 3 or 4 or 5, depending on what this looks like or what the index is. The index goes right here. It's a little number that tells you how many factors it wants. And those are identical factors. If there's no number here, then it's 2. The default is 2. If, however, you have something that looks like this, it's asking you what number multiplied itself 3 times gives me 27. And again, the fastest way to answer that is to do a factor tree. So you have 3 times 9 is 27, and 9 is 3 times 3. Okay, so you need 3 identical factors to pull out 1, 2, 3. So the answer is 3. Okay, if you had this, you want the cubed root of 8. That means what factor multiplied times itself 3 times gives me 8. Factor it out. 2 times 2 is 4 times 2 is 8. So the cubed root of 8 is 2, because you have 3 identical factors of 2 right here. So it's like the opposite. It's like undoing. It's the inverse operation of an exponent. You can multiply to get the 9 with your exponent, or you can factor it out to find the root factor using the radical symbol. Okay, they are the inverse operations to each other. Okay. Here's another example. What if we had the 4th root of 81? How would we find that? Well, we know that 81 is 9 times 9, right? Those are identical factors, but there's only 2 of them. We need 4. We know that 9 is 3 times 3. And we could do that to apply that to both of these. So 3 times 3 times 3 times 3, that's 4 3s. 4 is the number we're looking for. So we know the 4th root of 81 is 3. Okay? All right, so let's move on to some practice problems with roots. And this is 19.5. So let's simplify the square root of 64, the 4th root of 16, the 3rd root of negative 27, and the negative square root of 81. Now, something I want to point out before we get started is when you have a square root or an even root, you will never have a negative symbol under here, because any number, if these were all negatives, negative 3 times negative 3 times negative 3, you have 2 pairs here. Whenever it's an even index number, you cannot have a negative here, because there is no number, no negative number that you multiply it by itself an even number of times that will give you a negative root or a negative base. It'll never give you a negative product. It will always be positive if this is even. If you get a negative number to find this a root of, then there's something wrong. That is unsolvable. You cannot solve it. So you would just write no solution and move on. Okay. But if you have an odd index here and here, then you can have a negative, because a negative multiplied an odd number of times gives you a negative result. So keep that in mind. If this were a 2 or a 4 or a 6 or an 8 or a 10, you couldn't have a negative here. But a 3 is okay because it's an odd number of negative signs, and that is a potential result. So let's look at the square root of 64. Because there's no number, it's asking us what number times itself, just 2 times, is going to give us 64. Well, we know, if we know our multiplication tables well, like we should, we know that 8 times 8 is 64. So the answer to this is 8. All right, and now the 16, the fourth root of 16. We need to get 4 identical factors that give us 16. So let's factor this out. We know that 4 times 4 is 16. And that's a 4, but that's not what it's asking for. It's asking for 4 identical factors. Well, we know that 2 times 2 is 4, and we can do that all the way across. So that's 1, 2, 3, 4 identical factors, so the answer is 2. All right, now we're over here. We know that 3 times 9 is 27. So it's 3 times 9, but those are not identical. We know that 9 is 3 times 3. And if we make that a negative 3, we have an odd number of negative factors, so that's going to give us a negative result. So the answer is going to be negative 3. Okay. Now if we have a negative on the outside of the radical sign, then it's just asking for us for the opposite of this result. And we know that 9 times 9, because we did it up here, 9 times 9 is 81. But it's asking us for the opposite of 9. Well, the opposite of 9 is negative 9. So all you have to do is solve this and slap that negative symbol on there, and you're good to go. So let's move on. We have one more section. Pause this and take notes if you need to. I'm about to clear the page. This last section is the evaluation of powers. And the evaluation of expressions with exponents is straightforward when the replacements of the variables are all positive numbers. So all we're going to do is we're going to put in or sub in some values for variables that have exponents. So let's look at the first problem. And we have 4 options here. We have a squared, we have negative a squared, and we have negative a cubed, and then our final is negative a all cubed. Okay, what would be our value for each of the following if a is equal to negative 2? So let's start with the first one. If a is negative 2, then negative 2 times negative 2 is going to be a positive 4, right? Here we have the opposite of a squared. So negative 2 times negative 2 is 4, but we want the opposite of that, so it's going to be a negative 4. Right? Here, a is negative 2, and we're going to multiply it 3 times. So it's going to be a negative number. So negative 2 times negative 2 is 4, and 4 times negative 2 is a negative 8. But we want the opposite of negative 8, so that's going to be a positive 8. Now here, it's included. We want the opposite of negative 2 3 times. So what we have to do is get the opposite of negative 2. What is the opposite of negative 2? It is 2. So we're going to have 2 3 times. So 2 times 2 times 2 is 8. Okay? All right. So we have 2 more problems to evaluate. 19.7. Sorry, this was 19.6 up here. 19.7 says x squared, z cubed, and y. That is our expression. So we know, based on these exponents, that this is saying x times x times z times z times z times y, correct? All right, so if x is equal to 2 and z is equal to 3 and y is equal to negative 2, what is our result? So what we're going to do is we're going to just sub in these values here. So we would have 2 times 2 because x equals 2. Z is 3, so we would have 3 times 3 times 3, and y is negative 2. So negative 2 for y. That's all this is up here. 2 times 2 times 3 times 3 times 3 times negative 2. We have a single negative, so we know our response, our product is going to be a negative number. 2 times 2 is 4. And 3 times 3 times 3 is 27. So 4 times 27 is going to be 58. And 58 times negative 2, is that right? No, it's 108. Sorry, not 58, 108. And 108 times negative 2 is going to give us a negative 216. And that is how you would solve a problem like that. All right, one more, and I think I can do it right here, 19.8. I'm going to give you the problem, and I'm going to allow you to solve it yourself. Here's our values over here. P equals 1, M equals negative 4, and Z equals negative 2. All right, I would like for you to pause the video and solve the problem, and then press play and check and see if you got the same answer I did. All right, if you got a positive 24 for 19.8, then you are correct. And if you didn't get it, here's what you should have done. So I made a bucket for P. I made 2 buckets for M because M has a 2 here. And then I said minus, I brought down my operation, and Z was an exponent of 3, so I made 3 buckets for Z, right? So I dropped in my value for P, and I dropped in my values for M and my values for Z, and then I did the math. I did negative 4 times negative 4 is 16 times 1. You could have said 1 times negative 4 is still negative 4 times 6 times negative 4 is 16. And then I skipped my operation just for the sake of figuring out what this sign was over here. And I said negative 2 times negative 2 is a positive 4 times negative 2 is a negative 8. Well, the opposite of a negative 8 is a positive 8. So that meant 16 plus 8, which gave me 24. So if you did not get 24, you need to look at, did you drop a sign somewhere? Did you forget to multiply your negative symbols? Did you forget to take the opposite of the 8? Those are things that you need to check as you're doing your problem. But if you got positive 24, congratulations. You're doing well, and I will see you in lesson 20.